Hi, my name is Andrew Heimerman, and I'm the lead solution engineer at Staex. And today in this short video, I'll be talking about UDP and TCP and what the difference is between them. So first off, what are UDP and TCP? Well, both UDP and TCP help control data packets being sent over the internet from one machine to another. So they're essentially transport protocols. And now if we look at the OSI model, or the Open Systems Interconnection model, which represents the different layers between application and physical, like the bare metal machine, we'll see that transport layer, or where TCP and UDP reside, is layer number 4, right between the application layer and the physical layer down here, which would be the electrical signals. So what are the main differences then between these two protocols? Well, TCP, or Transmission Control Protocol, is a connection-oriented protocol, which is designed for creating a channel to share data packets. That means TCP organizes and sends out packets in an orderly way and ensures that they get delivered to the end machine that you want it to. UDP, or User Datagram Protocol, is connectionless, meaning that it operates on a more fire and forget principle. So that means if you say, I want to send it to one machine, it'll send it to that direction and not really care if it actually ends up getting there. And we can actually represent these both in an example using a mailman. So let's say the mailman was using UDP. Here he is with the parcel that he wants to deliver to the house. With UDP, he simply goes to the house, leaves the parcel, and goes away. He doesn't care if the person gets it. He doesn't care if it's multiple package, if the right package is in order. He simply just leaves it at the house and hopes for the best, essentially. Now on the flip side, we have TCP. So let's bring the mailman back here. Now first, before he even goes to the house, he says, "Hey, are you there?" He waits, and then the recipient comes and says, "Yes, I am." Then the mailman comes, brings a package, delivers it to the person who's living there, and leaves. But as he leaves, the person says thanks, acknowledging that he received the package correctly. Now that's how TCP works. TCP waits, it checks to see if it can make a connection, waits for a response, sends the data, and then waits for another response that the data got there okay. And that's the fundamental difference between TCP and UDP. So why, if we have these two different things, two different protocols, what's really the difference? Why wouldn't we want to use TCP all the time? Now, oftentimes we do, but there are certain advantages of UDP over TCP. So for one, is lower latency. We saw obviously there's one message that has to be sent through the network versus 3 with TCP. There's also less overhead for UDP because it doesn't have to do all these control mechanisms like ordering the packets or giving more information for how to deliver the packets and such. We actually have only 8 bytes versus 20 bytes or more with TCP. And the last advantage that I have here for UDP and TCP over TCP is that UDP can actually handle larger numbers of devices that need to intercommunicate. And that's because of this lower latency, this one message versus 3. Think if we could have actually 3 different devices which would send the same amount of communications over the network as one TCP connection. So those are some of the advantages of UDP over TCP. Now on the flip side, the advantages of TCP are that you have an ensured delivery, like we mentioned before. You have a for sure ordering of your data packets, so if something gets lost in transit, it'll be resent back to it makes sure that that packet ends up being delivered in the proper order to the proper recipient, whereas UDP does not do that. So you have the correct ordering of packets and resending packets that get lost, and you can also handle a high network congestion. TCP actually has a built-in algorithm. There are several different versions of these algorithms for different versions of TCP, but I won't go there today. But they can actually help handle congestion in the network. So if you could imagine the network as a pipe and you're trying to push packets through, at some point there could be too many packets. And you need to say, okay, well, stop the flow of packets coming in because I need to get the packets out of the other end of this pipe. TCP essentially acts as a gatekeeper for the pipe and says, here, let's slow down the stream a little bit. let everybody into the pipe or in an organized way so that we can get it out to the thing, to the proper recipients at the other end. Now this adds some latency, but it does in fact handle the issue of a large amount of packets being sent through the network. So why did Staex base our protocol on UDP? Well, we wanted something that was fast. Like I mentioned before, there was low latency, and we wanted something that could handle a high number of connected devices. Because of the UDP the low requirements for number of messages for UDP, both of these are fulfilled by it for us, for our needs, since we're building a large peer-to-peer distributed network. Devices also can come on and offline frequently. Since TCP is connection-based, that can actually break the pipe that would send the messages through, and you'd have to restart the whole process of connection again. Whereas UDP can it can handle a little bit more fluctuation. So maybe you miss a packet, but maybe it's not really that important for your use case. Maybe it's just one data point that you can go without. UDP can handle this online and offline device switch better than TCP. But we didn't just let it sit there and be like, oh, you know what, if we lose packets, that's okay. We actually were able to build in some of the functionality of TCP, such as network ingestion to help reduce the drop packets. We implemented some type of ordering and delivery system to be like TCP so that we can actually ensure that packets do get to their destination, but just at with a lower overhead than TCP. So overall, why we chose UDP is for the flexibility, and because we could implement a lot of the things that TCP offers in a more optimum way for our large-scale peer-to-peer network. So I hope that you learned a little bit today about UDP and TCP and what their differences are, and why you want to choose one or the other. And also why we at Staex chose UDP as the base for our solution. Now, if you want to go further in depth on this, there's another webinar that is a bit longer, which talks about the actual implications of using these different protocols in industrial environments for robots. And you can also find more information about how our solution works, Staex, at staex.io. And if you have any other questions, you can feel free to reach out to me at andrew@staex.io. So thanks for watching and have a great day.